Okay, for number 11, this is your pizza problem. So you have $22 to spend on pizza. It costs $12 plus 60 cents for each additional topping, tax included. Write and solve an inequality to determine the maximum number of toppings the pizza can have. And then once you solve it and round your answer, I want to know, is your solution reasonable? Explain. So first, for the inequality, we know we have 12 plus 60 cents for each additional topping, which would be 0.60x, with our toppings representing x. Okay? So we would say that our inequality would be 60 cents per topping plus a $12 for the pizza, and you have $22 to spend. And I would have to put that would be less than or equal, because I cannot spend greater than 22. I can only spend $22 exactly, so that's equal, or I can spend less than $22. Okay, so over to the side, I'm going to rewrite that inequality, and I need to solve it, which is just a two-step inequality. So I subtract 12.60x less than or equal to 10, and then divide by the 0.6. Well, 0.60, same thing. So if I divide, we get 16.66 repeating. So 10 divided by 0.6. Yeah, 66 repeating, okay? So rounding rules tells me I should round that up to 17. But if I round it up, I won't have $22. I need more than $22. So I need to round down to 16. So always round down. Now, is 16 toppings reasonable? Well, yes, it is. Because you must round down, since we can't buy more than $22. So I'll let you write that down. Yes, because you must round down, since we can't buy more than $22. Okay, for 12 and 13, we have our compounds. Okay? Our compounds were either and or ors. Okay? So and is here, or is over here. So for and or, we need to solve it, and then we need to graph it. Okay? So for and, we have two lines that we can draw. Okay? And your goal is to get that x by itself. So if I add 10 to 6, like if I were to cover this up, I would normally add 10 to 6, which is absolutely correct. But I also need to add it to the other section over here. Okay? So this would give me negative 8 less than 4x less than 16. Still do not have x by itself, so now I need to divide all sections by 4. So this gives me negative 2 less than x less than 4. Okay, so now to graph this, we need to have negative 2. So that would be negative 1, 0, 1, 2, 3, 4. And both of these inequalities do not have a line. So that means that we have an open circle if there is no line. And then it's an and, so we just connect. We connect our two dots here. Okay? For or, we go ahead and we solve this one like a two-step right here. Then once it's solved, we solve this one like a two-step. And then we put our two answers together here. So for the first thing we would do is we would just subtract 1. We divide both sides by 3. And then we get 1. So we bring down the word or. And then we solve this one. So we're going to add 5. And get 12. Divide by 2. And get 6. So we have x is less than or equal to 1, or x is greater than 6. So on our number line, we need to have 1, 2, 3, 4, 5, 6. At 1, we have a closed circle because it has the equal to, the little line right there. So I will go ahead and close that in. And then for 6, we have an open circle because there is no line. And then or means like opposite. You're going opposite directions. So I need to draw one arrow going one way and one arrow going the other way.